So this is our fourth problem, continuing our previous type, that is derivative of logarithmic function. Here you see that this is a very complicated problem. X raised to 5 multiplied by tan cube x multiplied by e raised to x upon x square plus 1 into sine square x. So if you see this example, uh, there is no term written in x raised to x or f of x raised to f of x form, but still we are going to use log here. Why we have to use log? If you don't take log for this example, then the other technique is you have to use properties uv u upon v properties, and along with that you have to use composite also. And to differentiate using that technique, it will be very complicated, and using log you will see that this problem will get converted into formula type and it will be very simple for you. So in such problems where there are many terms in multiplication as well as in division, we have to take log. Even if it is not written, you can take log. So taking log on both sides. So left side is y, log y. Then right hand side is log of this whole question term we have written here. Now using log x plus log y is equal to log x into y, and log x minus log y is equal to log x upon y. Using these two properties, both properties we will use in reverse order for this. So all the terms in the numerator we have to write in addition form. Log x raised to 5 plus log tan cube x plus log e raised to x, and all the terms in the denominator we have to write in the subtraction form, minus log of x square plus 1 minus log of sine square x. So here you have to note this, that however terms, however many terms are there in the question, all numerator terms which are in multiplication we will add here in logarithmic form, and all terms in the denominator we will subtract. Okay, so again, using third property of logarithm, that is log x raised to n equal to n log x. So all powers you can write here, 5 log x, then 3 into log of tan x, then x into log e, then here 2 into log of sine. So all powers we have taken down. So you can see that if you see the main question, this is so complicated problem in multiplication and division. But here in this step, after taking log, you can see that each terms are simple terms in addition and subtraction form. So it is not very difficult to find derivative of such terms which are in addition and subtraction form. But for some terms like log of tan, then log of sine, log of x square plus 1, for these terms we have to take derivative using composite also, because these are not simple functions. And you should know that log e is 1. If you take x down here, this will be x into log e, and log e, value of log e is 1. Therefore you can write only x term here, only x. Okay, so we will take derivative of y. Left side it is only y, so derivative of y is 1 upon y into dy by dx equal to, so taking derivative of left side, that is log y, it will be 1 upon y into dy by dx equal to derivative of log x will be 1 upon x using formula for log x. Then derivative of log of tan, this is composite function, so derivative of log will be 1 upon tan multiply by derivative of tan here, composite function, plus derivative of x, that is 1, value of log is 1, therefore this whole term will be 1 only, minus log of x square plus 1. So taking derivative of this log f of x, 1 upon x square plus 1 multiply by derivative of x square plus 1, okay, minus 2 multiply by log of sine, derivative of log of sine will be 1 upon sine into derivative of sine. Okay, so here 5 multiplied by x, 5 by x, 3 upon tan x, 5 upon x plus 3 upon tan x into sec square x plus 1 minus 1 upon x square plus 1 into 2x. What is 2x? Derivative of x square plus 1 will be 2x plus 0 minus 1 upon 2 multiplied by 1 upon sine will be 2 upon sine into derivative of sine will be cos. Okay, so from left hand side you can take this y to right hand side and write here, and whole derivative term you can write here. So y, we have seen many problems. Y will be the question part. So a whole question, that is y, we will substitute here, and along with this derivative we can write here. So we will see one more problem. This is a next problem on logarithmic differentiation. Here y equal to x raised to x raised to x raised to x. For infinite times there are x terms. So here, if you think this is very tough problem, it may seem tough problem for some of you because there are many x terms. But if you use log and a simple logic, this will be very simple problem. This may become a very simple problem for you. So here I have marked after only one x, all other x I have marked in one bracket. And you know that if there are x terms infinite times, if you eliminate only one x, the remaining, if we eliminate only one x from infinite x, the remaining terms here, these will be only infinite times x only. So here I have written that all these x are also infinite times x. So you can replace this with y only, because x raised to x raised to x raised to for infinite times is equal to y, that is given in our question. So this is very important. If you understand this, only then you can understand the problem which is solved further. Please try to understand this part only, because the solution is not difficult, only this part is a bit complex. So here it is now y equal to x raised to y, taking log, derivative of log y, sorry, taking log on both side, y will be log y, and right hand side it is log of x raised to y. So y you can take in the uh, here in down here, y multiply by log x. Okay, now take derivative with respect to x. Derivative of log y will be 1 upon y into dy by dx using composite technique. And here we have to use uv formula. So this is our u, this is v. So log x multiply by dy by dx plus y multiply by 1 upon x. 1 upon x is derivative of log x, and dy by dx is derivative of y. Using uv formula we have written this derivative. Now as in our implicit type function, we have seen that if there are more than one dy by dx terms, then we have to write all dy by dx terms on one side. So therefore, this dy by dx term, we will take it to left hand side, and we will write like this: 1 upon y dy by dx minus log x into dy by dx equal to y upon x, taking dy by dx common from both of these terms. So here only 1 upon y will remain, minus log x from second term will remain, equal to y upon x. Okay, so dy by dx equal to this bracket we will write in the denominator part. So if you want to solve further, you can solve, but this much answer is also sufficient. Thank you.